We've got it.
Then I'll get it. And
You got it?
yeah.
So this is all just a repeat of what we did last class anyway. Everything up through me starting to write this stuff down. Okay, so for the particular case, this is the billiard ball problem. Remember we did the first collision with billiard balls? We can solve this analytically because what we had the cue ball going purely in the y direction, we had the object ball stationary, they have the same mass, so that fits all our restrictions. So we can solve this analytically. So this is the billiards collision from left. So the setup on that was like so. We have x over here, y over here. We had the one ball, the object ball, started off here with this being at 0.25 meters. This being also at 0.25 meters. We had up here the object ball with this, that being at 0.28 meters, and this being at 0.5 meters. That's the setup for the billiard ball problem. With this guy right here heading off this way at U1, where U1 equals 1 meter per second. The magnitude of it equals 1 meter per second. That was their setup. Okay? And so these two balls are going to, this one's not moving, this one's going to go up, they're going to make contact, and we're going to need to figure out theta. It's kind of the first thing we're going to have to figure out, basically. Because we know U1, I mean, to get started here, we know U1, we don't know theta. So that's where we're going to have to start with. So I'm going to, yes?
Why do we need to draw that absolute volume on all of these?
It's just that if I'm terming as a vector, if I did it as U1 sub y, then I wouldn't. And this isn't absolute value, this is magnitude. Absolute value is just a slightly different thing. So if I say negative 3 absolute value equals 3, so that's absolute value. You just kill the negative sign. This is a magnitude. So then if I have,
So otherwise you
3I plus 4j, okay, this is some vector, I don't know, whatever, f, some vector f equals that, and I want to know the magnitude of f, okay, I'm going to say that's fine. Okay? This is a triangle. Easy. Okay? We got 3 squared, 9, 4 squared, 16, add them together, 25, 6 squared, we get 5. So that's magnitude versus absolute value. Alright. So I'm going to redraw these a little bigger so we can try to figure out what theta is. So at the time of collision, I have my object ball and I have my cue ball here. And the relevant facts of the situation are that, so I'm going to draw a line from their line of contact from the two centers like that, and draw that guy in there. I'm also going to put this in like that. This is 90 degrees. I'm drawing those vertical horizontal lines. Shoot that at 90 degrees. So what do we know about this triangle that would help us find theta, which is going to be right here. So this is going to be trying to find theta. That's the goal of the exercise right now, is to find theta. Yeah, we know U1. U1, we're done with U1. U1 is 1 meter per second right there. We need to find theta. Well, is U1 going to matter?
Well, we know the distance between the balls from our graph, right? We know our x and our y dimensions, don't we?
We do. Now, obviously, the y has changed because this guy's been heading up, going northbound here in the y. So the y's changed, but it hasn't changed in any different
radius.